What we're going to look at now is graphing quadratic functions. So before we graphed the lines, we had the generic equation of a line y equals mx plus b. As long as we knew our y-intercept and our slope, we could graph our line relatively easily and quickly. Quadratic functions doesn't really work as easily as a line, so there are a couple different options we have. Algebraically, mathematically, what we have to do is we use the axis of symmetry formula to find the x value of our turning point. We then plug that x value into the equation to find the y value of the turning point, and we will determine if it's a maximum or a minimum. So again, maximum if my leading x squared is negative. It's a minimum if x squared is positive. We make a table of values and we plug the values in around our turning point, and we can graph the points that we came up with. For example, what does that look like though? So for example, we have this first problem, y equals x squared minus 4x. So our first step, find the x value of our turning point. So x equals negative b over 2a. So again, x squared, ax squared plus bx plus c is our generic standard form of quadratic equation. So a is always on x squared, b is always on x, c is always the standalone number. So according to our problem, a is 1, because it's on x squared, there's no number, so we can presume it's 1 automatically. B is always on x, so it's negative 4. So we're going to plug them in here. So negative value of negative 4 all over 2 times 1. So we end up with 4 over 2, which gives me an x value of 2. Now we have to figure out the y value. So I'm going to plug in the value of 2 into my equation. So y equals 2 squared minus 4 times 2. So we end up with 4 minus 8, which gives me negative 4. So my turning point is the point to negative 4. So I go left 2, or I go right 2 and down 1, 2, 3, 4. So there is my turning point. Now, what we want to do is create this table of values that they're talking about. So table of values means I have this little chart. One side is going to be x values, one side is going to be y values. So in the middle, the turning point is going to be 2, and we already know it gives me a y value of negative 4. So what I want to do is I'm going to pick a couple points that are below 2 and above 2. So 2, 1, 0, and 3, 4. So now I got 5 points. It's going to give me a general view of what my parabola looks like. So I'm going to plug these values into the equation we have to figure out the y value. So if we have 1, so the other one is going to be 1 squared minus 4 times 1. Gives me negative 3. And if I were to plug in 0, so we have 0 squared minus 4 times 0. Gives me 0. Now if I plug in the value of 3, so 3 squared minus 4 times 3 gives me negative 3. And then if I plug in 4, so we end up with 4 squared minus 4 times 4 gives me 0. So notice we have repetition here. That's what we want to see. If we have a parabola, we're going to see repetition like this. So 0's on the outside, 3's, and then negative 4's in the middle. So we're going to plot these different points. So we have 0, 0, 1, negative 3, and we already took care of 2, negative 4. We have 3, negative 3, and 4, 0. And what I'm going to do now is I'm going to create this like a curve. It's a curve. It's not a connected dots with a straight line. We have a curve. So we're going to do a curve as best as we can, and then arrows at the end of it. So we're going to do the best that we can to draw a curved parabola through each of these points. So as long as it looks like it should, then we are good with that. So now state the following: domain, range, and is the above graph a function, yes or no? So domain is left to right. So we have arrows on the ends of our parabola here. So this means forever and ever, I'm going to be going left and right. So because I go left forever, I go to negative infinity. And then I go to the right and up on the other side. So because I'm going right and up forever, I'm going to positive infinity. And I'm using parentheses here because we can't technically hit infinity. So parentheses means we get infinitely close, but we just never really hit it. We use brackets if we solidly hit that point. Now the range is the y values bottom to top. So I'm going to go through, I'm going to come up, and what's the first y value that I hit? Well, it's the y value of our turning point, -4. So because I solidly hit it, I'm going to use a bracket, and then arrow goes up forever and ever. So we use infinity, and again we close it with a parenthesis because we can't technically hit infinity. Do we have a function here? Well, a function means that I were to draw a vertical line through the graph. I only hit one spot, and that would be anywhere on our graph. As long as we only hit one spot, we have a function. If there was any one spot where I hit 2 or more, automatically it fails the vertical line test, and we don't have a function. In this case, we are going to pass the vertical line test. So yes, it is a function. It passes the vertical line test. So that's what it means to use the axis of symmetry formula to find our turning point, and then you create a chart or a table to figure out other x and y values that would wrap around our turning point. Now number 2 gives us a little bit of a stipulation. It says graph f of x negative x squared minus 2x plus 3 over the interval -4, which is less than or equal to x, which is less than or equal to 2. So again, it's an interval because we're only covering those x values from -4 to 2. And what I want to do is I want to do the same thing that I did in the previous problem. I want to find the turning point, create a table, and find points that would wrap around our turning point. So step 1, x equals -b over 2a. So according to this, a is going to be on x squared, which is -1. B is always with x, which in this case is -2. So I'm going to plug these two values into our equation. So negative value of -2 all over 2 times -1. So I end up with 2 over -2, which gives me an x value of -1. So now what I want to do is I want to find the y value by plugging in -1. So we end up with f of x equals negative value of -1 squared minus 2 times -1 plus 3. So -1 squared, so we can now do negative. So we have -1 squared minus 2 times -1 plus 3. And we get 4. So our turning point is -1, 4. So left 1 and up 4. So there is my turning point. So again, we need now to create a table, x, y values. We already know -1 and 4 are going to be in the middle, so I'm going to pick 2 numbers below it, -2, -3, and then 2 numbers above it, so 0 and 1. And what I'm going to do is I'm going to plug values in to our given equation. So -2 squared minus 2 times -2 plus 3 gives me a value of 3. And then if I do negative 3, so we have the negative value of negative 3 squared minus 2 times negative 3 plus 3 gives me 0. And then if I plug in 0, so we have negative value of 0 squared minus 2 times 0 plus 3, I get 3. So notice we're starting a little wraparound. So we had 0, 3, 4, we're back to 3. So if I plug in 1, I should end up with 0. So we have the negative value of 1 squared minus 2 times 1 plus 3. And I do get 0, so we're good there. So now what I can do is I can plot the points around negative 1, 4. So negative 2, 3, so back 2, so left 2, up 3. And then negative 3, 0, so left 3, right on the x-axis. And then 0, 3, so right on the origin, up 3. And then right 1, right on the x-axis. So again, it's a curve, so we're going to connect the dots as best we can. And again, we want to go from negative 4 to 2. So we actually only went to negative 3 and 1. So according to us, we actually have to go to 2, and we also have to use negative 4. So again, we just do the same thing. Negative value of negative 4 squared minus 2 times negative 4 plus 3 gives me a value of negative 5. So negative 4, negative 5, and 2 is going to give me the same thing, negative 5. So left 4, down 5, and then right 2, down 5. So again, it's a curve. And notice I'm not drawing arrows at the end because I'm only going to x value of negative 4 and x value of negative 2. So state the following domain left to right. So left to right, we hit negative 4 first, again using bracket, and we only go to 2. And then the range is going to be bottom to top. So if I come up to the bottom, I see I hit the y value of negative 5. And my top value is 1, 2, 3, 4. So there's my range, negative 5 to 4. Do we have a function, yes or no? And we don't even have to do the vertical line test because they told us it is a function right at the start because our equation started with f of x. Anytime our equation starts with that, it is a function. So yes, because the equation begins f of x equals. So that is graphing quadratic equation using the axis of symmetry formula and plugging in different x values to find the y values. The other way that you could do it, if you're trying to save time, is go to y equals on the calculator and plug in the equation. So if I wanted to graph this particular one from example number 2, I would do negative x squared minus 2x plus 3. And in order to graph it, I would go to the table, because if I just hit graph, it's going to show me the graph, but it doesn't really tell me anything. So to plot the points and to graph it, I go to my table, and they actually gave us the domain, negative 4 to 2. So I want to go to x value of negative 4. And fortunately for me, on the screen, I see we go from negative 4 to 2, and I don't have to worry about anything else. And notice the y values we get are the same y values we had in our table. So these are the points, negative 4, negative 5, negative 3, 0, negative 2, 3, negative 1, 4, 0, 3, 1, 0, 2, negative 5. Again, notice we have wraparound, we have repetition, negative 5s on the ends, then 0s, then 3s, and then 4s in the middle. That's what we look for when we're trying to graph a parabola. I want where the y values end up repeating themselves. And I can plot those points, And if it's a straightforward equation, we put arrows at the end. If we have an interval like this, we would just plot the points that we were told to. In this case, it was -4 to 2. So that is graphing quadratic equations and determining domain range.